Why are there not more people talking about the incredible moons of our solar system? Get ready for an extraordinary journey through the moons of our solar system. Our focus? Moons. They're dynamic, intriguing worlds in their own right. Get ready, space fans. Let's uncover the wonders of the cosmos together. Let's start with a familiar friend in the night sky, our very own moon. Now, you might think it's just a pretty face, casting a gentle glow upon us, but it's so much more than that. This celestial dance partner plays a vital role in our existence. The moon's gravity is a powerful force, literally tugging on Earth and creating tides. But that's not all. It also acts as a cosmic stabilizer. Imagine a spinning top wobbling as it slows down. That's what Earth's rotation would be like without the moon. Its gravitational influence keeps our planet's tilt in check, ensuring a relatively stable climate with predictable seasons. Can you imagine a world where summer lasts for decades, followed by an equally long winter? Thanks to the moon, we don't have to. But the moon's influence goes beyond our planet's mechanics. It has inspired countless myths, legends, and scientific discoveries. For millennia, humans have gazed up at its cratered surface, wondering about its origins and its place in the cosmos. And in 1969, we did more than just wonder. We took a giant leap for humankind by setting foot on another celestial body for the first time. The Apollo 11 mission wasn't just about planting a flag, it was about pushing the boundaries of human exploration and understanding. Those lunar footsteps left an indelible mark on human history, but the moon itself bears the scars of a much older story, a story written in impact craters and vast plains of volcanic basalt. Each scar tells a tale of cosmic collisions, of a tumultuous past when the solar system was a much more chaotic place. So, the next time you look up at the moon, remember, it's not just a silent observer. It's an active participant in the cosmic dance, a celestial time capsule, and a testament to the human thirst for exploration. Now, let's shift our gaze to Mars, a planet that has captivated the human imagination for centuries. But Mars isn't alone in its journey around the sun. It has two small moons, Phobos and Deimos, named after the Greek gods of fear and panic. And let me tell you, Phobos, the larger of the two, is living up to its name. This moon isn't content with just orbiting Mars. It's on a collision course, slowly spiraling inward towards its planetary host. Now don't panic just yet. This cosmic drama won't unfold for millions of years. But the fate of Phobos is a stark reminder of the immense forces at play in our solar system. Gravity, that invisible hand that shapes the cosmos, is pulling Phobos closer and closer to Mars with each passing orbit. But what will be the final act in this celestial drama? Will Phobos crash into Mars, creating a massive impact crater? Or will it be torn apart by the red planet's gravitational pull, its fragments forming a ring around Mars? Scientists are still debating the ultimate fate of Phobos, but one thing's for sure, it's a fascinating example of the dynamic nature of our solar system. It's a reminder that even celestial bodies are not immune to change, to the relentless forces that shape the cosmos. Now, in stark contrast to Phobos's dramatic destiny, its smaller sibling Deimos orbits Mars at a more leisurely pace. This diminutive moon, barely a blip in the Martian sky, is a study in contrasts. While Phobos is destined for a fiery demise, Deimos will likely continue its quiet dance around Mars for billions of years. So, we've met Phobos, the daredevil moon spiraling towards a fiery Martian embrace. Now, let's meet its sibling, Deimos. Unlike Phobos, Deimos is a quiet observer. It's smaller than Phobos, just 7.5 miles across. Imagine finding that with your backyard telescope. Deimos, named after the Greek god of dread, ironically inspires anything but. Its surface, smoother than Phobos, is blanketed by regolith. This cosmic dust gives Deimos a ghostly appearance. It's like the quiet kid in the back of the class. But don't let its size fool you. Deimos holds secrets to the solar system's past. Its composition hints at a formation beyond Mars's orbit. How did Deimos end up in Mars's gravity? It's a cosmic ballet, with gravity as the choreographer. Deimos and Phobos were likely captured by Mars's gravity. They've been waltzing around ever since, silent witnesses to Mars's evolution. Imagine standing on the surface of Mars, gazing up at the night sky. You'd see two faint specks of light, Phobos and Deimos, tracing their paths across the star-studded canvas. Phobos, the larger and closer of the two, would appear as a bright, fast-moving star, traversing the Martian sky in just a few hours. Deimos, on the other hand, would be a more subtle presence. This tiny moon takes about 30 hours to complete an orbit, just a bit longer than a Martian day. This means that Deimos would appear to move very slowly across the sky, taking almost 3 days to rise, set, and rise again. Imagine the stories ancient Martians might have told about these celestial wanderers. From Mars, Deimos wouldn't look like a full moon as we see it from Earth. Instead, it would appear more like a bright star, perhaps even mistaken for a distant planet. This is because, unlike our own moon, Deimos doesn't reflect much sunlight. Its surface, covered in dark, dusty regolith, absorbs most of the sunlight that reaches it. Despite its subtle appearance, Deimos plays a crucial role in our understanding of the Martian system. From the serene dance of Deimos, we're catapulted to Io, the most volcanically active world in our solar system. Io is a raging inferno of fire and brimstone, a testament to the immense power of Jupiter's gravitational pull. Imagine a world where the ground is constantly shifting, where molten lava bursts hundreds of kilometers into the sky, painting the surface with hues of yellow, red, and orange. These aren't your average volcanoes. We're talking about plumes of sulfur and sulfur dioxide erupting at thousands of kilometers per hour. These plumes paint vast streaks across Io's surface and even reach space. Io's dramatic volcanism comes at a price. Its surface is constantly being reshaped, with lava flows paving over old craters and creating vast plains of solidified magma. It's like a cosmic etch-a-sketch, with Jupiter's gravity acting as the knobs, constantly redrawing the landscape. But there's more to Io than just fire and brimstone. Beneath its tortured surface, scientists believe there might be a global magma ocean. This molten layer, sandwiched between Io's core and its thin crust, fuels the moon's relentless volcanic activity. Imagine the scientific insights we could glean from studying such an extreme environment. However, studying Io up close is no walk in the cosmic park. The intense radiation belt surrounding Jupiter would fry any spacecraft that dared to venture too close. It's a harsh reminder that the cosmos, for all its beauty, can be an unforgiving place. From the fiery depths of Io, we journey to Europa, an icy moon with a hidden secret, a vast, potentially life-harboring ocean. While Io is all fire and fury, Europa is a study in cool, serene beauty. But beneath its icy shell lies a story as captivating as any volcanic eruption. Imagine a world encased in a shell of ice, crisscrossed by a network of reddish-brown cracks and fissures. These markings aren't just superficial blemishes. They're telltale signs of the dynamic processes happening beneath Europa's frozen exterior. Scientists believe that beneath this icy shell, perhaps tens of kilometers thick, lies a global saltwater ocean. This ocean, potentially containing more water than all of Earth's oceans combined, is kept liquid by the tidal forces exerted by Jupiter and its other moons. It's like a cosmic slushy, constantly being stirred by the gravitational pull of its celestial neighbors. But this isn't just any ocean. The presence of water, combined with internal heat generated by tidal flexing, raises a tantalizing possibility. Could Europa harbor life? It's a question that has captivated scientists for decades, fueling missions and sparking our imagination. The possibility of life on Europa is more than just speculation. Scientists have detected evidence of water vapor plumes erupting from Europa's south polar region. These plumes, likely originating from the subsurface ocean, offer a tantalizing glimpse into the moon's hidden depths. Imagine the scientific treasures these plumes could hold. By analyzing their composition, we could gain unprecedented insights into the chemical makeup of Europa's ocean, including the presence of organic molecules, the building blocks of life as we know it. This possibility has spurred NASA to develop the Europa Clipper mission, a spacecraft designed to conduct multiple flybys of Europa, studying its icy shell, subsurface ocean, and the intriguing plumes. It's a mission fueled by the fundamental question that drives our exploration of the cosmos: are we alone? Europa stands as a beacon of hope in our search for extraterrestrial life. It's a world that reminds us that even in the coldest, most alien environments, the potential for life, however different it may be from our own, can still exist. Ganymede. Just saying the name evokes a sense of scale, of grandeur. And it should, because Ganymede isn't just any moon, it's the largest moon in our entire solar system. That's right. Forget our moon, folks. Ganymede is bigger than the planet Mercury. Now, you might be thinking, big whoop! It's just a big ball of rock and ice. But you'd be wrong. Ganymede is a fascinating world with a lot more going on than meets the eye. For starters, it's the only moon we know of that has its own magnetic field. That's right, a magnetic field. You know, like Earth's magnetic field, which protects us from harmful radiation from the sun. This suggests that Ganymede has a molten iron core, much like Earth. And where there's heat, there's potential for, you guessed it, liquid water. And that's not all. Ganymede also has a very thin atmosphere, probably created by charged particles interacting with its surface. So, we're talking about a moon with a magnetic field, a possible subsurface ocean, and an atmosphere. Starting to sound pretty interesting, isn't it? Now, let's talk about that subsurface ocean for a minute. Scientists believe that Ganymede's ocean could be sandwiched between layers of ice, kind of like a cosmic Oreo. And here's the kicker. This ocean could contain more water than all the oceans on Earth combined. That's right, folks. We could be talking about a moon with more water than our entire planet. Now, I know what you're thinking. Neil, are you telling me there could be life on Ganymede? And the answer is, maybe. We don't have any evidence of life on Ganymede, but the presence of liquid water is certainly a tantalizing clue. Callisto. The name might not be as catchy as Ganymede, but trust me, this moon is just as fascinating in its own right. You see, Callisto is like the solar system's punching bag. Over billions of years, it's been pummeled by asteroids and comets, leaving its surface covered in craters. Now, you might think that a heavily cratered surface would be boring, but you'd be wrong. Each crater on Callisto tells a story of the early solar system, when collisions were common and planets were still forming. By studying these craters, scientists can learn about the types of objects that were flying around in the early solar system and how often these collisions occurred. But Callisto isn't just a record of the past. It might also hold clues to the future of our solar system. You see, Callisto is a very old moon. In fact, it's one of the oldest objects in the solar system, and because it's so old, it's had a lot of time to cool down. This means that Callisto's interior is probably still relatively pristine, like a time capsule from the early solar system. By studying Callisto's interior, scientists can learn about the conditions under which the moons and planets formed. And here's the really exciting part. Some scientists believe that Callisto might have a subsurface ocean, just like Ganymede and Europa. Now, Callisto's ocean is probably not as deep or as salty as the oceans on those other moons, but it's still an ocean. And where there's water, there's always the possibility of life. Titan, Saturn's largest moon. But size isn't everything, and Titan is so much more than just a big moon. In fact, It's one of the most Earth-like worlds we've ever discovered. Now, I know what you're thinking. Earth-like? But Titan is a moon, and it's really, really cold. And you'd be right. Titan is a moon, and it is incredibly cold, with surface temperatures hovering around -290 degrees Fahrenheit. But here's the thing. Titan has something that no other moon in our solar system has: a thick atmosphere. Not only does Titan have an atmosphere, but it's an atmosphere that's actually denser than Earth's atmosphere. And what's this atmosphere made of, you ask? Well, it's mostly nitrogen, just like Earth's atmosphere. But here's where things get really interesting. Titan's atmosphere also contains methane. Now, methane is a simple organic molecule that's often associated with life. And on Titan, this methane exists in a liquid state. That's right, folks. There are actual lakes and rivers on Titan, but they're not filled with water. They're filled with liquid methane. Imagine that for a second. Sailing on a methane lake under an orange sky with Saturn looming large overhead. It's a scene straight out of science fiction, but it's real, and it's happening right now on Titan. But the methane isn't just sitting there. It's part of a complex chemical cycle that scientists are still trying to understand. Sunlight interacts with the methane in Titan's atmosphere, creating a kind of smog that blankets the moon. And some scientists believe that this complex chemistry could be a precursor to life, or perhaps even a sign that life already exists on Titan in some form we don't yet understand. Enceladus, one of Saturn's many moons, might seem small and insignificant at first glance. It's a tiny ball of ice reflecting sunlight back into space. But don't let that fool you, because Enceladus is one of the most exciting places in our solar system. Why? Because it's one of the few places where we've actually seen active cryovolcanism. Now, you might be thinking, cryovolcanism? What's that? Well, instead of spewing out molten rock like volcanoes on Earth, cryovolcanoes erupt with water, ammonia, and other volatiles. Think of it like a giant icy geyser, and these plumes on Enceladus? They're not just a cool visual. They offer us a glimpse into what lies beneath the moon's icy shell. You see, these plumes originate from a vast global ocean hidden beneath the surface. And where there's water, well, there could be life. That's right, Enceladus, despite its small size and icy exterior, has all the right ingredients for life as we know it. Now, we haven't actually found life on Enceladus yet, but the evidence is incredibly compelling. And that's why Enceladus is right up there on the list of potential targets for future missions to search for extraterrestrial life. Imagine sending a probe to Enceladus, equipped with instruments that can analyze the chemical makeup of those plumes, searching for telltale signs of biological activity, or even landing a spacecraft on the surface and drilling down through the ice to directly sample the ocean below. The possibilities are truly mind-boggling. And who knows, maybe, just maybe, Enceladus holds the key to answering one of humanity's oldest questions. Are we alone in the universe? Until then, we'll continue to observe and study this fascinating moon, eager to unlock the secrets it holds. Because Enceladus is a powerful reminder that even in the coldest, most unexpected corners of our solar system, the potential for life might be lurking just beneath the surface. Neptune, the icy giant of our solar system, holds sway over a retinue of moons. But among them, one stands out as a true enigma: Triton. Now, most moons in our solar system orbit their planets in the same direction as the planet's rotation. It's kind of the cosmic norm, you know? But Triton dares to be different. This icy rebel actually orbits Neptune in the opposite direction, a retrograde orbit, if you want to get technical. It's like swimming upstream against a raging cosmic current. What could explain this rebellious behavior? Well, astronomers believe that Triton wasn't originally a moon of Neptune at all. Instead, it was likely a wandering object from the Kuiper Belt, that region beyond Neptune, filled with icy remnants from the early solar system. See, Neptune's immense gravity snagged Triton, pulling it into orbit. But the capture was a bit messy, leaving Triton with its unusual retrograde orbit. Triton's rebellious streak doesn't end with its orbit, though. Oh no, this moon has more surprises in store. You see, Triton is one of the few objects in our solar system known to be geologically active, despite its incredibly cold temperatures. And by geologically active, I mean it has geysers. That's right, geysers erupting not with molten rock, but with nitrogen. These nitrogen geysers shoot plumes of material high above Triton's surface, creating a thin temporary atmosphere. These geysers are a sign that Triton is far from a dead, frozen world. Beneath its surface, a subsurface ocean of water and ammonia may exist, kept warm by tidal forces generated by Neptune's gravity. So, not only is Triton a captured world with a rebellious orbit, it's also an active world with nitrogen geysers and the potential for a subsurface ocean. Talk about a moon that keeps us on our toes. It's further proof that our solar system is full of surprises, waiting to be uncovered. From the volcanic fury of Io to the icy plumes of Enceladus, the moons of our solar system are a testament to the boundless diversity and wonder of the cosmos. These aren't just companions to planets, they're worlds of their own, holding secrets about the past, present, and possibly even the future of life in the cosmos. As we continue to explore the universe, these natural satellites remain some of the most exciting destinations for future discoveries. They challenge our understanding of planetary formation, offer tantalizing hints about the potential for life beyond Earth, and remind us that our solar system is a place of constant change and evolution. Thanks for watching, and don't forget to like, share, and subscribe for more cosmic journeys.